Okay. All right, here we go. Standard normal distribution. Good morning. Good Monday morning. Isn't it Monday morning? Okay. I don't know. Okay, so last week we talked about some normal distributions. And we did one with women's heights. In your homework, maybe you had men's heights. I can't remember what the different normal distributions were. But there's a lot of normal distributions. And a lot of things will follow a normal distribution. And those distributions may have different centers and different spreads. The standard normal distribution always has, and very few, well, a lot of things actually follow a standard normal distribution, but few things in life follow a standard normal distribution, because the standard normal distribution has a center that mu is 0, and a spread, that being the standard deviation, of 1. Okay? So this distribution, I try to draw in the little curve first. And then I mark the center, because it's hard for me to make the peak where I marked the center. There's the center. The center is 0. I go and look for what I call this point of inflection. Go right here. There's one standard deviation to the right of 0. And so that would actually be 1 on my x-axis.
Did we do this already?
So we did this for, I don't think we actually defined this as a standard normal distribution. I think we did this for women's heights or something like that.
Okay.
Yeah. So it's same thing. It's still a normal distribution. So it still has that same rule, or that kind of rule, that 68, 95, 99.7. Okay. So I'll go out 2 standard deviations and 3 standard deviations. Mark those on my graph. And I'll go -1, -2, and -3 standard deviations. And so my x-axis will actually be, instead of kind of like heights or something like that, it actually is numbers of standard deviations from the center. So I'll abbreviate that STD DEV. Why not? This isn't health class, but we can still talk about STDs here. Okay, my x-axis is the number of standard deviations from the center. Now, we had some measurements that we did last week. We said that if I had my center here and I went plus and minus 1 standard deviation, I get 68% of the area.
Yes.
And then 95, we had the 95 at -2 and +2, and 99.7 between -3 standard deviations and +3 standard deviations. So some people write this kind of like this. Oops, I guess with a line here. And then 99.7 all the way to here. Oops, to here. And there we go. And that's fine for getting some generalities here. But then we started breaking this graph down a little bit and looking at percentiles with this thing. And that very quickly becomes, this 68, 95, 99.7 very quickly becomes way too general and not enough numbers for us. So we need to find area under this standard normal distribution, like say between 1.4 and 2.7. And there's 1.4, approximately 2.7. For instance, we need to be able to get some areas under this curve at some oddball situations, and we don't want to integrate this curve every time to do this. So there's a couple of ways to get these oddball areas, and one of them's by a table, and I will show you how to use the table, and the other way is through your calculator. So obviously the easy way is through your calculator. The a little bit harder way is the table, and the hardest way would be to do the definite integral. Yes. Oh, okay. So I'm not going to use 1.4 quite yet, but we'll get there. But yeah, we'll say this is between 1.4 standard deviations above the mean and 2.7. All right. So here's what we can do. First, let's use the table, which you'll find to be very annoying. And let me show you what the table looks like. And if you have your textbook, I believe it's the back inside cover. No, it's in the front. And I'm going to show you, well, that's not what I wanted to show you.
Can we use a calculator?
Yeah. Oh, here we go. This is the one I want to show you. This is a standard, these are the standard normal probabilities. This table, did anybody find it in your textbook? Is this in the front of your textbook?
Yes.
Okay, in the front. There we go. Right inside the front. You get 2 pages of this, and it's going to tell you the area under the curve, always starting at negative infinity and going up to whatever number you're going to tell it. And so they're calling that a z because we'll often just get a z-score. If we're using a normal distribution that isn't centered at 0, we'll use a z-score. So they call that up to a z. Okay, so let's say I wanted to go from negative infinity out to negative 1. Anybody remember what that area was from what we did on Friday?
No.
Okay. There's 50% from 0 and to the right, and another 14%. 64, so that's got to be 16%. Okay. Now we're going to look this up. That's an approximate. That's an approximate value. We're going to look this up on this funny table, and we're going to find a closer to an exact value. In your calculator, you're going to get an even better value. So on the table, we went to negative 1. On the table, we're going to find negative 1 over in the left-hand part of this table. Oh, now here's the negative 1 line. Do I need to zoom on this a little bit more? Here's the negative 1 line. Okay, so I looked at this table, and I'll look down until I find negative 1. And then across the top gives me the next digit, gives me the hundredths digit. So if I wanted to look at negative 1.00, it's 0.1587. Okay? If I instead needed to look at negative 1.08, I go on the negative 1.0 line, 0, 1, 2, 3, 4, 5, 6, 7, 8, and that would tell me the area under the curve is 0.1401.
Wait, I don't get it.
Okay? So what I want to do is, let's say I needed to instead find the area under a normal distribution from negative infinity to negative 1.08.
Well, why is it negative infinity?
The table only works with negative infinity. That's why the table's not as easy to use as your calculator.
Wait, what if you want to find like negative 1 to
Oh.
negative 2.4?
Good question. But we got to work our way to it. We got to be able to read the table first.
All right. So this
Okay.
is for negative infinity to whatever.
So we'll get there.
I get it.
So we estimated it from that 68, 95, 99.7 rule that should be negative 1. But when I look it up on the table, I get 0.1587. Okay? So it's pretty close to 0.16. That 68 rule was kind of approximate. Okay? So then if we went to, I said if we went to negative 1.08, and I'll call this the proportion or the probability that z is less than negative 1.08. Oh, sorry. I need to be over here. My table gave me 0.1401. Okay?
Wait, is that the area?
That's the area. That's the green area. Okay? Let me give you another one. What if I needed to find exactly the area from negative 1 to positive infinity?
Oh.
Okay? How would you do it?
You go to the table, flip from 1.
Oh, so if this area is 0.1587, the area on the other side is 1 minus 0.1587.
So the table only works for negative.
Right, but then you have to manipulate a little bit more when you want to go to positive infinity. So the probability that my z is greater than, we said negative 1, is, what's 1 minus 0.1587? Thank you. Okay. For those of you who have taken calculus, does it matter if I say greater than or equal to? Yeah. So if I just add in that 1 point at negative 1, area under that one, under the curve at 1 point is 0, so it is the same. If I put a greater than instead of a greater than or equal to, it's all the same. Okay, here we go. So that's how I do those areas there. All right, because I want to go back to that other problem, and I want to find the proportion. I said 1.4. That z is between, what was my original problem? 1.4 to 2.7. Okay? I want to see if you can figure out how to go from 1.4 to 2.7. Okay? Work with your partner for a few minutes on this and see if you can come up with a way to do this. If you have your table available, then you might want to look in a book and see these exact numbers. But you can ask me for these numbers from the table if you like.
Like you scroll up, so.
Yeah, I know you want to see this. Okay? Yep.
So why does it matter that we got the right key and then
Oh, this is an abbreviation for what I'm asking you. I'm asking you the proportion of values under the curve, starting at negative infinity and going to negative 1.08. This is a way of writing that out mathematically. So get used to it. This is where you're going to see it.
the one on the right, so 1 minus 1.5 is 7.
So that was that 0.8413, yeah. Okay, are we thinking about how you can do this? Okay, so I'm going to let people have time to finish up their notes, and then I know some people are going to have some ideas for how we can get this one that we want.
So wait, you can do this one with the table,
Yes.
but you said it only works for infinity.
Yeah, so how can I do this one with the table?
Oh, I know.
Who want? Yes, ma'am.
Would you like go over to the negative and do like find the standard or the C-score for negative 1.4, and then you would take that C-score and do positive 1.4 minus that C-score?
So I don't actually have to go to the negative part of the table to do what you just said. So tell me again how to do this without going to the negative part of the table, changing it. I agree. You can with the symmetry we can go over here and get. Let me mark off what she was talking about. -1, -2, -3. She was saying that is the same thing as. Let me get a different color here. Blue. As this area over here from negative 2.7
Oh, it is. Okay.
so it is the same because of symmetry there. Those two are the same. Okay, but I need a plan now for how to get that. And so does it make more sense in your mind to explain it from the blue instead of the green? All right, so explain. I'm going to put a new picture down that's just the blue, because that's where she wants to explain it from. Now, what area should I be getting first? What would you give me a procedure for doing this?
Okay, so I just said that like, you would find the Z-score for the A negative 1.4 to -2.7.
Okay, but that I don't know how to do yet.
That.
You could,
Remember, I got to go from negative infinity. Yeah.
take the Z-score from negative infinity to negative 1.4.
Okay, hang on. Let me put that in there. So he did a Z-score from negative infinity to negative 1.4. And then what do you do?
Subtract the Z-score from negative infinity to negative 2.7.
Ah. So then he goes out and he gets this 2.7. Let me see if I can get this in a color that I can, it'll show up over it. I went too dark on the first one. Oh well, we'll just do it that way. And he's going to subtract off that little black part, and he's going to get that area between negative 2.7 and negative 1.4. So he takes the probability that z is less than or equal to negative 2.7. Okay, so let me go look in my table and find negative 1.4. Negative 1.40 is 0.0808. And then negative 2.7 is negative 2.70, 0.0035. And you said to subtract, so negative 0.07. Wait a minute. 8 minus 5 is 3. 80 minus 3 is. Oh, that's my problem. There we go. 0.0773. Here we go. Okay, so the proportion of the area between negative 2.7 and negative 1.4 is 0.0773, but that wasn't my question. My question is, what's the proportion of the area from positive 1.4 to positive 2.7? And what's that answer? So the reason that we did this was because you told us there was some symmetry. So what do I know about the blue area and the green area? I want to ask again. What do I know about the blue area and the green area? Same. So what is the proportion of the area from positive 1.4 to positive 2.7? Yeah, it's the same. Okay, last thing, how would you do it on your calculator? All right, so we got to find a command that's called a normal CDF, and that is under distribution, so it's second vars. So you hit the second and the vars key. And then you have to look for normal CDF, and it's number 2. Okay? So it says normal CDF. That's the one you want, number 2. So you put it in the number 2. Or you go to that and you hit enter. Vars, it's, can you... Okay, and you will tell it 1.4, you need a lower bound, so that's 1.4, and then an upper bound, 2.7. And what do you get? .7728 something, so it gets you a little more exact. Okay? All right, so obviously easiest with your calculator.
How do you type in like negative infinity?
Negative infinity, I would just type it in as a negative and a 1 and then put 10 zeros and you're fine. You've got it, it's enough. So if I just wanted to find the proportion of z's less than negative 1.8, I do the normal CDF. So this is how I'll abbreviate. I would go negative 1, just hit some zeros, doesn't matter how many, comma, negative 1.8, and that's close enough to negative infinity. Okay, for positive infinity, just leave off the negative sign. Just 1 followed by, hit as many zeros as you want, and you're good. Because when I'm greater than 100 standard deviations, my answer isn't going to change by much. Okay, let's get rid of this.